In this video, I want to take a second to review some basic math. Hopefully it hasn't been that long since you took some math and you remember basic algebra, a little bit of geometry, and even some intermediate algebra. So a couple things that we're going to be looking at in an intro to econ course, whether it's macro or micro. We spend a lot of time graphing, and we want to make sure that we understand basically how to find the slope, how to find, you don't need the first derivative in this class, however I'm going to show you, what we're talking about when we're looking at taking the first derivative, and how to find out if it's a minimum or a maximum on a function, which would be the second derivative, but calculus is not required for this class. But basically, let's look at, a basic slope formula. You're probably used to that y equals mx plus b. Well, in economics, we kind of move this around and we say that y is equal to b plus mx. Okay, so we're just taking the intercept and putting it at the front of the equation. So basically, if we have an equation of something like y is equal to 10 plus x's value obviously is 1, so the y-intercept over here is going to be 10, and we know that the slope of this function is going to be 1. Now drawing on this a function or even a straight line is actually relatively a pain, but let's say I just have to switch like 4 tools in order to get that. So let's say that looks like about slope of 1, which means the rise is 1 and the run is 1. Okay, so basically it's this slope is, y is equal to 10 plus x. Okay, so there are times that we'll see that the slope is going to change, the slope of the curve. Let's say that we find out that instead of y is equal to 10 plus x, maybe the slope of the curve changes. So we want to look at the difference between the intercept changing and the slope of the curve changing. If the slope stays the same and the intercept changes, we're going to have the same curve. It's just going to be a parallel curve directly under our original curve. Okay? So in this example, we would say that here y is equal to 8 plus x. Okay, so the slope of the curve stayed the same and these shifts are parallel. Now let's look at what happens when the entire slope changes. So let's say that we start off with a new function where y and x, where y is equal to 4 plus 2x. Okay, so we know that the y-intercept is going to be 4, and we know that we're going to come up to and go over 1 for rise over run. Come up to, go over 1. Come up to, go over 1. So that means that we are going to have a curve that's a little bit steeper. Let's say that a curve that looks like that. Okay, so that's going to be our y is equal to 4 plus 2x. So now just changing the slope, we're going to say we're going to graph y is equal to 4 plus x. Okay, so now the slope of x is 1. So it's going to be up 1 over 1, up 1 over 1. So if we were to graph that, we'd see that that about looks like a 1 over 1 slope. Okay, so in case you've forgotten the way that we find the slope, if we're given a line and we're looking for the slope, it's going to be the change in y and the change in x. So delta y and delta x. So that gives us the basic rise over run that you've been working with since about 7th grade. Okay, what else do we want to look at? In this class, we spend some time solving for two unknowns. So we can look at a very basic supply and demand graph. Let's say that we're looking at the market for used textbooks. And we are given the equation that the demand is equal to negative 3p plus 270. And the supply is given by the equation 100 plus 5p. Okay, so after studying supply and demand, you guys will know that there's a point where supply and demand are going to be equal, and we're going to call that the equilibrium point. So if I asked what is the price, that should be an iron, price and quantity in equilibrium, you would start off by setting these two equations equal to each other. So we would have negative 3p is equal to, negative 3p plus 270 is equal to 100 plus 5p. Now we would simply isolate the variables and have 170, subtract 100 from that side, so have 170 is equal to, bring this 3p over here, 8p, so that we find out p, and we'll put a little star next to it. P is equal to 21.25. We just divide both sides by 8. So now that we have our value for P, we can go up and stick it into the supply equation or stick it into the demand equation. They will be the exact same. So we can see that demand is equal to negative 3P plus 270, and we know that it's negative 3 times 21.25 plus 270, and that is going to be, what is that, 63 3/4, so 63.75, 63.75 plus a positive 270, so we find out that demand is equal to 206.25. Okay, and then if we do the same thing, we'll find out that supply is equal to the same amount. So setting two equations equal to each other, solve for the two unknowns. Pretty basic again. The last thing that we want to look at is, let's just kind of draw out a quick function, and let's say that we are looking at some sort of function that looks like that. Okay, so without going into too much of a math or a calculus review, let's just look at a couple different points on this graph. Okay, so if we were to look at the slope of this curve without calculus, we could very easily find the slope of this curve by taking any point on the curve and finding the slope at that point, because obviously the slope on this curve is constantly changing. A couple things that we can tell is the slope starts off negative. How do we know that it's negative? Well, if you're on the y-axis and you were to hop off onto a skateboard, you would instantly start going downhill. So that means that this is a negative slope. Then you would bottom out here, and the slope, you wouldn't go anywhere. You would sit for a second. If you came down with a decent velocity, you might move. But if you just started at this point, you would not go anywhere. So the slope right here we see is 0. Then over here, you would actually have to kick on your skateboard in order to get up. So this function starts off negative, hits 0, starts off, and then starts coming positive. Now again, at this point, at the very, very top of the mountain, and this mountain has a little tiny point where it's a singular point where you're not going uphill and you're not going downhill. So again, we have a slope of 0 right there. And then you start coming downhill, and this is obviously a negative slope. Okay, so how do we figure out the slope? Well, here we know that it's negative, and here we know it's 0, and here we know that it's positive. Well, if we were to draw a tangent line, which on this program will be almost impossible. If we were to draw a tangent line to a point. It would be a point that passes through, or it would be a line that passes through a point in exactly one spot, okay? So here, these blue lines that I'm drawing, oh, I obviously missed it. These blue lines that I'm drawing are tangent lines, okay? So we can easily figure out the slope of a tangent line, but even without doing that, that's just, taking 2 points on the tangent line and figuring out what the slope is. But I want to kind of draw a couple slopes, or a couple tangent lines right here, where I have a negative slope. Okay, that's obviously not the best, but this slope starting at 0, as we go down, it's getting steeper in this area. It's very steep, very steep, very steep, and then it starts to flatten out. Up here, it's a little bit flatter. So this slope is decreasing at an increasing rate, okay? And over here, we have a slope that is increasing. It's very, very steep, and then it starts getting a little bit flatter. So over here, it's still a positive slope, but it's increasing at a decreasing rate. These tangent lines will become flatter and flatter and flatter until they hit 0. Okay, so that last one wasn't close enough. So flatter and flatter and flatter until they hit 0. So this is an increasing slope, however, it's increasing at a decreasing rate. So this obviously, just looking at the function, we can pretty much tell that up here, this is the maximum of this part of the function right here. So if we look right here, the slope at these 2 points are equal. They're both 0. So that would be the first derivative in calculus. If you've had second derivative, then you know obviously this slope right here, the second derivative is going to be negative, so it's going to be a minimum, where the second derivative of this slope right here is going to be positive, so this is going to be a maximum, and this is a minimum. But even without calculus, we can pretty much tell that just by looking at it, that this is obviously the minimum of this function in this area, and this is the maximum of the function in this area. Okay, make sure that you spend some time going over basic math if it's been a while. There are going to be times that we are going to use a little bit of geometry as well. Basically, if we have some sort of, make it a darker color, if we have some sort of graph and we are trying to figure out different areas, let's say that we want to figure out the area under the curve. Obviously, if this is our demand curve, we would be able to find that 1/2 the base of this triangle, 1/2 the base times the height, is going to give us the area under the curve. So if this is our price and this is our quantity, if we find out that this is $100 and the quantity is, let's say, 50 units, then obviously we could figure this area out, that it's 1/2 the base, which is going to be, I'm using this as the base for some reason, it doesn't matter which one you use, times 50 units. So obviously we can just take 1/2 and divide through like that, and we'll see that it's going to be $100 times 25, or $2,500. Okay, so basic geometry, you'll all obviously need basic algebra, intermediate algebra you should also have, and if you've had calculus, that's awesome. However, you won't need it for this course. Okay, now we're ready to hop right in.